All right, let's solve the same problem using alpha beta. So alpha beta is a layer on top of minimax that just makes the search more efficient and drops whole subtrees from having to be evaluated. So it saves computational resources. So alpha really just stands for the minimum, and beta stands for the maximum. So in alpha beta we use a depth-first search, and this one we proceed more algorithmically in evaluating how the search proceeds. And so we're going to evaluate left to right, and that's just a bias because as English speakers, we read left to right. Other cultures may do it differently. So we'll do a depth-first search, and we arrive at a level down here. We've gone down 3 levels, and that's where we've decided to evaluate scores. Because remember, this is just this, we have a player who's trying to figure out what to do, and they may need to respond quickly to the next player's move. So they can't go infinitely deep in this graph. It takes too much resources and too much time. So in this case, we've gone down this many layers, and maybe we'll do another search to go down further until our time expires. But in our current evaluation, we've gone down 3. But there's no magic to how deep you go. It's just based on how much time you have and how quickly you need to respond. Okay, so we're doing a depth-first search. We're proceeding down this way. We find 10. So at this point, this is a minimizer layer. So min is going to set its max value. Now, that's a little confusing, but this is the biggest number that it's ever going to return for this subtree. So this will be 10. And so basically we're saying this number is going to be less than or equal to 10. Beta is going to be less than or equal to 10 for this node. Then we continue our search, we find 250. So now we know that alpha beta for this cell are going to be 10, 10. At this point, max knows it sets its minimum value. It's going to be greater than 10. We don't know what the real max is, but it knows the floor, which is going to be 10. And so we continue our exploration. We backtrack. Oh, this will be 10. I should write that in there. We continue our exploration. We backtrack here, and we recurse down to 17. So at this point, min knows the biggest number it's ever going to get back, its beta value, is 17. Hasn't figured out what its minimum is, but right now it's the maximum it'll ever get back is 17. So then we find a 38. So it sets its minimum value to 17. This becomes 17 at this point. So we know here max knows at this point you'll have a choice between 10 and 17. So its max has gone up to 17, and it'll reset its min value to that too, because it knows it can get a 17 now. So we'll keep those values the same once we have established them. So now we do a big backtrack, and we go all the way over here and find a 6. And so min will know at this point that the maximum it's ever going to get back is a 6. And then we go over, and now we find a 0, which, okay, so min revises its max to 0, and the min will be 0. Basically, we decide on 0 for this node here. So we continue around here. So far, we haven't been able to drop anything, because at this point, we know, what do we know? We know max here, or min, excuse me, this is a min, that it's going to be less than 17. So its max value is less than 17 or lower. We don't know what its real min is going to be yet. Okay, so we found 0 for this node. We recurse down here, do the same thing. So the biggest it's going to return here is going to be a 3. And we find a 4 over here, so min drops that. Doesn't need to take a 4 because it already has a lower number. We'll assign that to be a 3. Let's see, I didn't do my alpha betas over here. So max new, the least it could get would be a 0. And the moment it sees this 3, it's going to update that to a 3 or better. And then it knows, because those are the only 2 values it has, it'll, basically has to return 3. So now min at this point, we're able to say this is going to be a 3, and it doesn't have to take the 17 anymore. It's going to stick with the 3. So that was the same answer we got last time. We weren't able to make this more efficient. It doesn't always work, and in this case it didn't. But that's the idea behind minimax, and while it didn't help us this time, it certainly does in many cases.